Welcome back to the Super Data Science Podcast, everybody. Super pumped to have you back here on the show. Today's guest is Dr. Kirk Borne. Kirk, how are you going today?
I'm doing very well, Carol. Thank you.
Where are you in this uncertain time? Where are you located?
I'm located in my house. Oh, just kidding. I'm located in Maryland, just outside Baltimore, Maryland.
Gotcha, Maryland. And you were supposed to be in Peru a couple of days ago, or a week ago or so.
Yes, I was a keynote speaker at the Data and AI Summit that was scheduled to be in Lima, Peru, but it went online and virtual.
How did you find that? Like, how you've presented, you've done keynotes at a countless number of conferences. How do you compare live events versus virtual events?
It's hard to compare, actually. It's a completely different experience. I like, for example, I do like being in front of a live audience. Frequently, I tell jokes. I move around the stage a lot. I try to engage with my audience. And, sometimes I will stare at them, make them realize I want them to stop and think about what I just said. And it's kind of hard to do that on an online environment. But on the other hand, I like online because I don't have to travel. I can be in my comfortable socks and have a nice cup of tea next to me, and it's fun to do that too.
Yeah, and comes with it brings like a lot of scale with the pandemic, which is unfortunate, but at the same time, a lot of people have tried out and have been open to online events, and that way, as you said, you don't have to travel, and any live event has a limited room capacity. With virtual events, not only you can do them like every single day, if there's availability, like there's no limit to how many you can do, or one per day, I guess. But also an unlimited number of people can tune in and watch you. So I think helps deliver that message to many more people.
Yes, the problem with that I discovered last week. I had 4 consecutive days where I had a keynote at a virtual conference, and I was exhausted by the end of the week.
Wow. That's a lot. Why do you do these keynotes? Like, what inspires you to go out there and speak to people and deliver the message of data?
Well, I'm a big believer in the power of data to change lives, change business, change outcomes in our world. And since everything is digital and data is being collected on just about every aspect of life, I think every person in the world needs to have some literacy around this. So I'm actually a firm believer in promoting, sort of advancement of science and education and math and education and technologies in education. So this is sort of my way of doing it.
Fantastic. Well, very excited, and thank you for coming on the show. We're definitely going to dive into this. I've got tons of questions for you, and if we have time, we actually also have questions from our community, which hopefully we'll get to. But before we get started, for those who might not know you, can you please give us a rundown of your background? And there's so many interesting things that you've done. In a nutshell, how would you describe your background?
Well, how many hours do you want?
We don't have more. I think we only have 1 hour, but
okay. Well, I've been in the. I went to graduate school in astronomy. Got a PhD in astronomy from Caltech, and that was 40 years ago. So it's been 40 years of amazing things I've been lucky to be part of. So I spent 20 years working on NASA projects. But first with the Hubble Space Telescope, and then as a contract manager in an office for NASA. And all those jobs involved data. I was always working with data systems for scientists. And of course, I would joke with people that my day job was data, but also my night job was data as an astronomer working with data. So I've worked with data in every aspect, my entire career. But after 20 years at NASA, I moved on to being a professor at George Mason University, which is located in Northern Virginia. And I was professor of astrophysics and computational science. But actually, I never taught an astrophysics course while I was there, because I started there 17 years ago. and with the vision of starting a data science degree program. Because after 20 years doing data at NASA, I realized the importance of data and data science for the world. So we actually launched that program 14 years ago at George Mason. So I did that for quite a few years. And then 5 years ago, this company, Booz Allen Hamilton, found me and offered me a job I couldn't refuse. Fantastic position, fantastic people I work with, and interesting projects. And I almost got to create sort of my own job, so to speak, do the things that I love the most. And that's how they described the job offer to me. What do I want to do? And I said, I want to promote this to the world. I want to educate the world. I want to advise and instruct and mentor and tutor people about data science. And that's what I do.
Well, wow, very, very concise history, but very exciting as well. So I love the whole 20 years at NASA, as you mentioned before the podcast. Given that your name is Kirk, Captain Kirk from Star Trek. Did they really call you Captain Kirk at NASA for 20 years?
Well, I wouldn't say professionally they called me Captain Kirk, but certainly my friends called me Captain Kirk. In fact, some of them, when they see me, even though I left that NASA job many, many years ago, when I see those people, they always say, "Hey, Captain."
Hey everybody, hope you're enjoying this amazing episode, and we've got a quick announcement and we'll get straight back to it. And the announcement is that Data Science Go Virtual number 2 is in town. It's happening on October 24th, 25th this year, and you can get your tickets today at datasciencego.com/virtual. And the best part, it's absolutely free. We've got some amazing speakers, amazing workshops for you to attend, and of course the super cool part is that we've got networking. There'll be several 30-minute speed networking sessions where for 30 minutes you connect with a random data scientist from another part of the world, or maybe from your part of the world. You get to chat for 3 minutes. If you like each other, if you want to connect, you hit the connect button, you stay in touch. This was by far one of the top features of Data Science Go Virtual number 1. So many people got such great connections, stayed in touch, and some crazy stories came out of that. So we're going to repeat it, and we want you to connect with your fellow data scientists. Once again, it's absolutely free. Register for your ticket today at datasciencego.com/virtual. And I'll see you there. And now let's get back to this episode.
About NASA, I have an interesting question for you. So in one of your talks, you mentioned that in 1997, I believe, you had a story where you were in charge of the astrophysics data. Oh no, you were in charge. You were the archive project scientist for the Hubble telescope, and I believe you had like 15,000 projects on your system, which in total took up a certain amount of space. And then you had an opportunity to bring on another project into the archives, and it was 2 terabyte worth of data. Can you tell us the story again? And also, the question I had there was like, what was big data back then, and how has big data evolved over time? What is big data now? How is it different?
Well, that's a lot of questions in one, but that's good. So I did spend 10 years with the Hubble Space Telescope project, and the last 3 of those 10 years, I was working with the Hubble Data Archive, which was the science data system for research astronomers around the world to access and to use the data for research. And after I did that, I got a position managing a contract. I was not a NASA employee, but I was working for a small company supporting NASA at the Astronomy Data Center, which was part of the Astrophysics Data Facility at NASA. And so there we were managing not just one experiment, like Hubble is one experiment, but 15,000 different experiments of astronomy and space science data. Now, most of those were small, very small. They weren't anything the size of Hubble, of course, but small little experiments that maybe sit on the back of a rocket where they collect a little bit of data. But we preserve those data for all time, because that was the job of the data center where I worked. It was almost like the permanent digital library of the data collected by NASA. Now, this is important because those missions and experiments were funded by tax dollars, by the American citizens. And so when the scientists complete their projects and research with the data that they collected from those NASA experiments, it was our job to take those data and curate them much like a digital librarian to preserve that data forever, not to lose it. So we had 15,000 experiments. And at the start of 1997, those 15,000 experiments totaled less than 1 terabyte. But then about that time, 1997, I met a colleague at a conference who he knew what I was doing. He knew where I worked. And he had an experiment project, a big team of people he was working with. And he told me that they were just finishing their project and they wanted to send their data over to us so that we could preserve it, curate it and save it for all time and make it publicly available to the worldwide community, which is what our duty was. That was our job. And when he told me that one single experiment was over 2 terabytes, it literally nearly broke the bank, so to speak. So we had 15,000 experiments, less than 1 terabyte, and one new experiment on top of the 15,000, which would have required us to triple the size of the data center, triple the capacity of the data center. Well, that for me was the first real aha moment about the growth of data in the world. That was 1997. Just unbelievable. Never even imagined one experiment could eclipse by a factor of 3 the sum total of the previous 15,000 experiments. And I think that was for me that sort of birth of the notion of big data, but also the birth of my interest in what we can do with that much data, i.e. machine learning and data science, or what in those days primarily we called it data mining. And so what's happened over the years, of course, is that everyone has at some point come to the same revelation that the amount of data they're collecting in their organizations and in their businesses, and even in their personal lives or in government agencies, sports teams, you name it, everywhere. Everyone's come to the revelation that this data is different from past data. People say, we've always had big data. Well, that's a funny statement because, we've had a lot of data, but we've never had something so comprehensive and deep and broad in the sense of so many different attributes. For example, we have so many different features and things that we use to describe customers and patients and describe movies and describe books. So all the different ways we could describe every instance of something in our world is what is really most interesting about big data. So I think the way it's evolved is less focus on the depth, that is how much we have, but on the breadth. How many different features do you have? The more sort of features you have, the greater what we call the 360 view. Do you create this sort of 360 view of whatever it is you're studying? Again, whether it's a customer or a hospital patient or even a baseball player or whatever it is, you're collecting so many different dimensions of information. You have deeper and greater insight than you've ever had before about anything. So in some sense, it's the emergence of small data that's really interesting right now. In fact, I just saw the latest Gartner report on emerging trends for 2020 in the area of data analytics. And one of the emerging trends is small data. And that is the focus on how much power and insight you can get from a small quantity of data, as long as you have many different dimensions and perspectives and viewpoints, which we call features in the data set. So that's, for me, we're coming back to sort of our roots here, which is, first of all, data management, that is being able to maintain and curate and make publicly, or not, maybe not publicly, but make available to the right community, whoever that community is, even if it's private data, making that data available in good ways, searchable ways, reusable ways, meaningful ways, but also realizing the more dimensions we have, the more we can integrate those different dimensions, the deeper our insights will be. So for me, it's really, I really feel like I'm coming full circle to my early days of working with data systems. But in reality, it's a whole new world, because we've never been able to get this much insight from so many aspects of our world than we can today.
That's very interesting about small data, that Gartner included that as an emerging trend. Why is that relevant now, when we have even more storage capacity, even more processing power? Why should we be cognizant of small data sets and delivering value from smaller data sets, rather than just put all the possible data we have into the equation, into the model, store all possible data we have? Well, why can't we just go bigger? Why are they saying that it's important to go to look at small data sets?
Well, first of all, I'm not saying we should not have the big data. Absolutely, we should. So my best sort of analogy for that is this. So let's say I walk out of the front door of my house. And I live in a neighborhood with lots of trees and things like that. Sometimes even the small animals run through the yard, like the deer. So if I were to walk out my front of my house and try to consume every bit of information that's coming to me, every single leaf on every single tree and every single piece of grass and every single thing that moves and how it moves and its color and its shape and its size, I would be overwhelmed. But instead, my cognitive ability, you might say my intelligence, not artificial, but natural intelligence, knows how to sift through all of those inputs to find the most important thing that I need to pay attention to. And so that will depend on whether I'm going out walking, or I'm going to respond to a neighbor's request for help, or I'm going outside to trim the bushes or to mow the grass, or to see if maybe there's some damage was done by the wind on the side of my house. So what I am paying attention to in the middle of all that information is the thing that my cognitive ability says, this is the thing you need to pay attention to right now, given the use case, i.e. the reason that I am out today. And so our data collections are like that. We don't know what the use case will be. It'll change from day to day. You don't know sort of what are the things that are going to be most important. And not only that, if you don't collect that data, you'll have such a narrow view of your world and such a narrow view of your environment, you'll have absolutely no idea whether you're making the best decision. So all of the data that we collect helps us to make the best decision at the right time in the right place. But it's the data science and the AI that helps us to do the cognitive thing, which is to narrow it down and sift through the data. That is to find the most important pieces and elements in all those streams of data for this particular application, this particular moment, and this particular decision the business is making. And that will change maybe day by day. It will change for the different people in the organization, the different components of your organization, different departments. So all those data are contributing to something. It's just that they're not all contributing simultaneously, because that would be ridiculous. But they do contribute at the right place at the right time, and that's what small data is about. And what AI and machine learning does for us, it helps us to sift through the data, to triage the data, to identify the most important thing. So really, one of my things I like to say to people, the most important value of AI nowadays might be just the triage that it does on our huge data sets to help us cognitively identify the piece of information and data that we most need to look at and make and base decisions upon.
Okay, I see. Makes total sense, and that ties in quite well with the whole IoT. I like your quote that Internet of Things is not about just the connectivity of devices. It's actually the way that these devices put things into context, that the way these data points, basically, I think this is a phrase that you used in one of your presentations. It's the Internet of Context. And I would love to understand a bit better how that ties into the fourth industrial revolution. I think you have a great way of describing it. Like, I understand the first versus the second versus third, but the third and the fourth industrial revolutions sometimes can be seen as similar, because one is about internet-based and computer systems, and the other one's about big data and IoT. Do you mind speaking a bit to that topic?
Well, first of all, the third industrial revolution, people focus on basically the birth of the internet and personal computing. It used to be that there were computers before 1969, which is sort of the date that people sort of declare as the start of the third industrial revolution. But there were computers before that, but they were basically in big government labs or big university labs, big industrial labs. So the internet basically allowed for flows of information between people. Right? So that's what we've been doing for many years, and sort of that computing power that we use for that purpose. But the fourth industrial revolution now is all about hyperconnectivity, and the flows that sort of mediated are the data flows. It's not just information; it's the data that's flowing through all of these nodes, if you will, that are informing the world through all these connections. So Industry 2.0 and fourth industrial revolution, 4.0, I should say, Industry 4.0, is really about that hyperconnectivity and delivering contextual information from these sensors. And when I say sensors, it's not just like a mechanical device. Even a social network like Twitter or LinkedIn or Facebook is a sensor, right? People leaving reviews on e-commerce pages to give reviews on different products and services, that's a sensor. So sensors are anything and everything, right? It's what we say, what we do, and it is also mechanical, electronic sensors of the world measuring things. So all of us are being sensors, and the Internet of Things is providing contextual information about all these other things. So remember what I said about small data lives in a world of big data. Small data is the thing you're paying attention to, but all the rest of the data gives you the context in which that thing is happening, is living, is acting, and dynamically moving. And so Internet of Things gives us all that extra context about whatever it is we're paying attention to. And so we're really now sort of mediating knowledge across the networks as informed by all these data flows. And so that's really a different way of thinking about the industry, so to speak. And that is information about customers, and information about supply chain, information about warehouse, about customer demand, even about weather and world events that affect supply and demand and so forth. So if you don't have all these extra contextual variables, you might completely miss what's going on and build the wrong product or deliver the wrong items to the store or not meet the needs of what customers want. So we need to basically tap into these additional sources of contextual information to help us make the best decisions. So I call the Internet of Things the Internet of Context, but two other phrases I use to describe it is context as a service, or in other words, insights as a service. And the other one is forecasting as a service. Because once you have these insights, how things are behaving, you start detecting the early warning signs of something changing or something about to happen. So forecasting, so to speak, comes not just from following a time series and predicting what the next data point will be in a time series. That's sort of old school forecasting. But modern school forecasting is about realizing there's all these contextual causal factors. And the more you tap into those contextual causal signals, the better you are to see what's coming around the corner, so to speak. And so forecasting as a service, insights as a service is just a way I like to just describe the Internet of Things, and again, Internet of Context.
Okay. Another thing that another quote that you mentioned once, or maybe several times, that every industrial age brings a change not only in the technologies, but also in the work that we do. What kind of change do you see happening now? Like, we've been going through this fourth industrial revolution for a while, and the change doesn't seem to stop. It's constantly more and more change. What kind of change are you seeing, and where do you think it's all going?
Well, the future of work is a major topic actually in the AI and data science world, dealing with automation and the digital transformation of businesses. And oftentimes people focus on the sort of the negative aspect, which is the jobs that will be lost. But what they don't realize is that for every revolution, there are jobs lost, but there are many, many more new jobs created. In fact, there was a World Economic Forum report on this 2 years ago, which said something like there would be, I can't remember the number, I think 58, I might have these numbers reversed. I think it was 58 million jobs would be lost. And people spent a lot of time and energy talking about that and focusing on that 58 million jobs lost due to the artificial intelligence and the digital transformation taking place now in the world, automation and those things. But they did not read the next sentence. And the next sentence says, and there will be 133 million new jobs created. 133 million new jobs created. So literally, there will be twice as many jobs available for every one job that's being lost due to this automation. So the work changes. For example, the first industrial revolution really put a lot of sort of farmers out of work. I like to say that 200 years ago, 95% of the workforce in the United States was farming, 95%. Now it's only 0.5%, 1/2%. But those farmers are feeding more than 10 times as many people as those farmers were 200 years ago. Technology has enabled that. Well, we don't have 99.5% of the country unemployed because all those people that were farmers 200 years ago are not farmers today. No, the work has changed. What we do is different. And that's the same thing is going to happen in this age of automation. So when I talk about AI with people, I say it's not about artificial intelligence. It's about amplified intelligence, accelerated intelligence, augmented intelligence. These things are augmenting the human in the loop. The human is now doing more high-level cognitive work, whereas the machine and the automation is doing the repetitive task. So it's actually making work better for people, creating more interesting jobs for people as they are assisted by these automations that have to do sort of the repetitive work that maybe gets kind of boring. And so I think we have to accept the fact that jobs will go away, but many more new jobs will be created. And that's just the nature of the evolution of business for hundreds of years.
I totally see your point there. However, you talk about, I liked your, in one of your presentations, you talked about combinatorial growth, that it's even faster than exponential growth. And the reason I bring it up now is with the previous industrial revolutions, whether it was the steam engine, the second one about the electricity-based mass production and computer internet-based revolution, there was time. There was time for people to retrain, to learn new skills, to requalify for new jobs, and to adjust their lives. To many people would say that this fourth industrial revolution is happening so fast, the change is so rapid, that is there time? Is there time for people, for these new jobs that will come? As you said, the 133 million new jobs. Will people have enough time to qualify for them, or to learn how to do these jobs, to adjust their lives and lifestyles? Some would say that perhaps it's very different to how it's happened in the past. What are your comments on that?
Well, that is definitely true. It is different, and it is much faster. But that's what it is. I mean, we can't change the course of history. This is what's happening now. It just so happens that the change is happening within the span of one person's career. But even from the first industrial revolution to the second to the third, the time between those major moments in business and history was already shrinking. I mean, it shrank from maybe 100 and some years between the first and the second, going from steam engine to electric power. Then from electric to the computer age, it was sort of like 50 or 60 years. And then from the computer age to what we now call the fourth industrial revolution, it's sort of like 30 or 40 years. So these numbers are decreasing. So 30 or 40 years is now less than a typical person's career, which basically means that you have to accept the fact that this is what it is. I mean, we can't, I don't think you can really stop what's happening. It's happening. And so it means that basically it's no longer true, even if it ever was true, that you basically finish school with whatever level of schooling you finish with, and then you can stay in that job and that profession till retirement 45 years later. That's just not the way the world is now, unfortunately or fortunately. I mean, I personally am excited by that because I believe in lifelong learning. I believe in constant learning. And I've sort of redefined myself and reconfigured myself over my career several times, from an academic scientist to a business manager, to an academic professor, now and all in astronomy, to now data scientist, executive advisor, and these things. So I'm not saying everyone has to do what I did, but I'm just saying one has to be agile enough, because it is an agile world that's demanded of us. So the changes are inevitable. Focus on lifelong learning is what I tell people. Focus on learning new things, but always don't do it just for the sake of doing it. Find the thing you're passionate about. Like, just say, for example, if you're really into medicine or sports or finance, all these organizations, banking, every one of the things in the world has, again, these sort of digital revolutions taking place. If you're in one of those fields, one of those industries, stick with it. If that's what you love doing, but the job you're going to be doing in that industry is going to be different.
Speaking of education, you created the world's first data science undergraduate degree program at George Mason. That was 13 years ago. What does the data science education space look like now, and how has it changed?
Well, it's changed quite a bit, and I wouldn't have believed it myself 14 years ago. So 14 years ago, myself and other professors at the university put a proposal in to the state of Virginia, because we were a state university at George Mason University. We put a proposal in to build an undergraduate data science degree program, a bachelor's of science in data science, which was approved, and we opened the program to students 13 years ago. And back then, I was really thinking very narrowly, actually. I was so passionate about bringing data science to the world and bringing it to students and teaching it, that I was thinking of it as sort of a profession unto itself. But really today, it's really embedded in systems, business systems, organizations, government agencies, nonprofits, everything. It's embedded. It doesn't have to be outside. It's fine if you are a data scientist and that's your entire profession. But data science itself, small d, small s, is an embedded thing to do in businesses, right? It's a way of doing things, I should say. And so what we see now is the focus more on the data science, data analytics, AI tracks in almost every discipline in universities. When I left George Mason University 5 years ago, it was quite interesting because 13 years ago we were like the first in the world to have a data science degree program. Now there's literally thousands, hundreds, if not thousands. And the other thing is, at my own university, we had business analytics in the business school. We had big data engineering in the engineering school. We had health informatics in the health school. We had data-driven education in the education department. We had policy informatics in the School of Government and Public Policy. There was even a sort of a data journalism track in the communications department. So it seemed like every department was taking hold of this and saying, yeah, our industry, our business, our domain is being overrun by data also. And so we need to train our students in these disciplines of getting insights, get data-driven insights from data, and improve decision-making through data. So every organization in universities department is doing this, just like every industry is now doing this. So now I'd like to say to people that data science is not a thing to do, but it is a way of doing things. And that's really what has changed dramatically in the last 13, 14 years.
So would you recommend for people to study data science as a separate degree, or to go and study something they're passionate about and incorporate data science in their path?
I think the thing that in your question there, it sort of answered itself. Follow the thing that you're passionate about. So if you want to be focused on data science in itself, that's great. Do that. I mean, one should do that. It'll teach you, you'll learn about coding and machine learning and algorithms and visualization and all the things that will carry you through all kinds of different interesting paths in life. If you're interested in doing something in another discipline, like I said, finance, marketing, policy, healthcare, sports, art, communications, you name it, there's going to be a digital component of that. So learn some data science, learn some analytics, learn some data visualization, learn some coding to help you in that career track. But first and foremost, follow the thing you're passionate about. So yes, there will continue to be a data science career track and degree track at universities and career track at employers. But that's just one track. The other tracks are going to be just the normal business functions, but every one of those people are also going to need to have some digital and data literacy.
That's great advice. I'd like to move into a bit more into data science itself. There was something in one of your presentations that I really enjoyed, and you spoke about 4 types of data discovery. You talked about class discovery, correlation or causality discovery, outlier or anomaly discovery, and association discovery. Do you mind sharing that with our audience? I think that can be very useful to anybody in the space of data science.
Yeah, so the context of that was frequently I'm asked to describe sort of what data science is and machine learning to people. And oftentimes these are audiences that don't have the mathematical background, and that's fine. And as an educator, that's perfectly fine for me because I love explaining things. Like I think it was Albert Einstein or somebody who said, if you can't explain it to your grandmother or if you can't explain it to a third grader, then you don't really understand it yourself. And so what I've learned over the years is the more I explain things to people and talk to people about stuff, the better I understand. And so when people ask me about machine learning and data science, I don't want to go straight into talking about supervised learning and machine learning and training sets and neural networks and all those kind of cool things. They are cool. I love those things. But what really helps people to understand what you're talking about is you put it in the context of what people already do. And this is sort of my belief, and that is machine learning is emulating the human intelligence. Artificial intelligence is emulating the human intelligence. Data science is emulating what we already do as human beings. We observe our world, we detect patterns in our world, and we learn what those patterns mean to help us make decisions and understand things. And so what kind of patterns are we talking about? Well, we're talking about clusters and groups of things. Humans are really good about seeing groups, clusters, and we segment things all the time. If you put some toys in front of a child, they'll start segmenting them by color, by shape, by size. They'll even segment them by function. They're not thinking about it, but a toy can be used to build a castle, right? You can use blocks to build a castle, but you use a ball. You can't build a castle with a round ball, but you can play a game with a ball. So very natural human thing is to cluster things. So class discovery is what clustering is about. When we start grouping things, we start seeing the different classes and groups that things exist in our domain, whatever your domain is. And this is the power of big data once again. The more data we have, the more we are able to discover new classes, sometimes rare classes, but also start learning what separates the different classes. What are the boundaries between those? So class discovery is not just learning that classes exist, but learning what distinguishes them. So that's the first one. So pattern discovery, first of all, is group and cluster and class discovery. So another example of pattern discovery is the second one you mentioned, which is correlation discovery. So humans are really good at seeing trends and patterns in things, right? So trends and pattern discovery, correlations is the second on my list. And that basically says that if you see a relationship between two variables, that's a correlation. That you can say, given X, find Y. Okay, given X, I can tell you what Y will be if X and Y are correlated. So correlation discovery is very powerful for forecasting and for all kinds of applications in life when you start seeing a pattern, right? And so even a child discovers if I touch the hot stove and burn my finger, I'm never going to do that again. Okay, there's a correlation between behavior and data. The data just happens to be a burned finger. That's still data. So correlation discovery is good for forecasting, but it's also good for another thing, not just predictive power discovery, but prescriptive. And what I mean by that is when you have extra dimensions, not just X and Y, but you have third and fourth and fifth and more dimensions. Some of those extra dimensions you may discover have some kind of causal influence on that first correlation that you found, X versus Y. Because X versus Y may not have any causal relationship. You learn this in statistics class, that correlation does not imply causation. That is, just because X and Y are correlated doesn't mean one of them caused the other one. However, as you add more data, more dimensions, again, the power of big data is the high dimensionality, the high variety that we're getting. We can find that unique dimension, which is the causal variable that maybe we can cause to affect some different outcome. So if we know that Y increases with X, but what if Y is something we don't want to increase, like risk, business loss, or customer loss, something like that? How can we decrease that? Well, we know that X correlates with Y, but how do we decrease Y? I just know there's a correlation between X and Y. I don't learn anything about how to change it. Well, if we find those causal factors that allow us to reduce Y, then we can change the outcome of that particular correlation to a lower value. But what if we want to lower Y? They want to decrease Y. We know that there's this correlation between X and Y. But how do we decrease Y? If we want, for example, decrease, I said decrease before, I think, but let's say we want to increase customer sales or increase customer satisfaction or increase employee experience or increase whatever. increase performance on a machine. Again, look for those causal factors that come through those higher dimensions in that correlation space. So correlation discovery gives us both predictive and prescriptive power discovery. So there's the first two. We have groups and clusters. Those are patterns. We have trends and correlations. Those are patterns. The third one on the list is outlier or anomaly discovery. Now, I like to just call that surprise discovery. That's the surprising, unexpected thing in your data. So the anomaly or the outlier doesn't have to be an outlier. It could be an inlier. There could be a data point or a behavior that's right in the middle of a crowd of data points, but you've never seen a data point at that particular spot in the middle of that data. That's an inlier. But that's an unusual, unexpected, surprising data point. So again, humans are very good at anomaly detection, at seeing things that are out of place, that are in a place where we've never seen something before. That they stick out, right? We call it sticking out like a sore thumb. That's the expression we use. All right, so the outlier or surprise discovery, again, could be inlier or outlier. They're anomalies, novelties, surprises. Those are things humans are good at, and we train our algorithms to do the same thing. So we train our algorithms on these three types of patterns: groups and clusters, trends and correlations, and these novelty or surprises. The fourth one is association discovery, the fourth type of pattern discovery, or I like to really call it just insights discovery. Fourth type of insight discovery is association or link discovery. Finding the associations and links across a network, across a graph. It's basically graph analytics. I think graph analytics is the most powerful tool in the universe for data scientists. Wasn't it Shakespeare who said all the world is a graph? Actually, he said all the world is a stage. But if he were alive today, he might say all the world is a graph, because what is a graph? It's about entities and relationships. It's about things and the relationships between them and what those relationships mean. Isn't that exactly what a Shakespearean play is all about? People and their relationships. And so in a graph, you can find connections across the graph. A may not be directly connected to C, but A may be connected to C through an intermediary B. You would never see that in a transactional database, but you see it in a graph database. Now, why would that be important? Well, A connect to B and then B to C, but no A to C directly would be an example of money laundering. It's also an example of marketing attribution. It's also an example of causal factor discovery. It's also a factor of illicit goods trading or illicit like human trafficking, for example. You never see A and C connected in any transactional database. So you can look through all the data you want, you would never see it. But A is connected to B, and then from B to C, you discover the connection between A and C. Now, it doesn't have to be a negative thing like the ones that like money laundering, but just a typical graph network that we use every day is a web search. When you do a web search, think about Google PageRank. It's all about the network of knowledge, the network of the links in the internet. And through that network, we can find things that we didn't expect to find because we identify relationships between maybe disconnected objects through their connections in the network. And so that's not sort of the most easy thing for a human to see. So it's not about a group or cluster. It's not about a trend. It's not about an outlier. It's about the more cognitive thing that humans do, which is seeing the connections among the disconnected things. I like to say connecting the dots that aren't connected. And so if we really want to be really a cognitive data scientist, then we should focus more on graph analytics and graph models of our data, not exclusively, but there's so much knowledge and insight to be discovered there, which is why I put that in its own place in my list of 4 types of insights discoveries.
Wow, that's super insightful. How can somebody learn more about graph analytics and get into that space?
Well, there's some really interesting new books that are out. You can search for graph algorithms and graph analytics. You might want to just start with a book on network science. So I got hooked on this years ago with a book called Linked. So Linked talked more about sort of the connections in human society. I'm sure you've heard of the phrase 7 degrees of separation. It talks about the connections between people and things and processes in our world. And it really wasn't a data science book, but I read it as a data science book. So start with something that's just very natural, describing our world, like linked. Then you can move on to the more technical books on graph algorithms and graph analytics and graph databases. It's just a powerful tool, and there is a lot of development this year. I've noticed a lot more development around graph analytics this year than I ever have seen. And for one reason, one of the ways that we can help track the movement of the, so to speak, the epidemiology of the coronavirus is through network science. Sometimes we call that contact tracing, but it's really network science. Who are you connecting with, and who are they connecting with? And is there a chance that you could be infected from some third party through an intermediary? That's graph science, network science. And so it's not just for that reason, but there's many use cases. Like I said, marketing attribution, causal factor analysis, all kinds of things that are empowered by graph models.
Would you say that recommender systems are a subclass of network science?
Yes, absolutely. A recommender system can be, there's different types of recommender engine models, but one of them is definitely the graph, the knowledge graph, or the product graph, if you want to call it. So knowledge graph, product graph, these are all examples of graph models. So a product graph, again, is that people who bought this product, you may also bought that other product, so you recommend this other product to you based upon its place in that product graph. But that's not the only way recommenders work. There's other kinds of techniques where they basically do predict whether you would like it or not based upon whether other people liked it or not who had similar shopping patterns to you. So there's lots of interesting things in recommender engine science, and that's how I really got hooked onto machine learning. Actually, 20 plus years ago, I started reading about the recommender engines. Amazon was one of the first to do it, and the sort of the mathematics and research was done in the computer science community before Amazon, but Amazon is the one who really took it to the bank. And I like to tell people it's pretty amazing. Amazon is a $1 trillion business. And this $1 trillion business, I've read 30% of the revenue of Amazon, 30% of the revenue of a $1 trillion business comes from an algorithm, the recommender engine algorithm. That is phenomenal.
Absolutely. You speak about three broad categories of AI and data science applications, namely image understanding, language understanding, and next best action understanding or decision making. So which one do you think, like if I'm a new data scientist entering the space of data science and I want to build a career here, and at this stage, I don't know what I'm passionate about, which one do you think would you recommend to focus on? Which one is going to, based on your expectations, going to skyrocket or really stand out in the coming years?
Well, that third one, sometimes I call context understanding. So you think about sort of data types, if you will. So images and language, and then all these other sensors in the world, right? So we got image understanding, language understanding, and context understanding. And context understanding really is about deciding what your next best action and next best decision is. Remember that AI is of no value unless it inspires a better decision or better action, right? So next best action understanding is really what all of it is about. But how does it do that? It does it through understanding the contextual data, not just images and words. So right now, I think both language understanding and image understanding are extremely hot topics. Computer vision, natural language processing, natural language understanding. I don't know if you've been following the news, but recently there's been in the news this algorithm GPT-3, which I can't even remember what it all stands for, but it's a third generation text autocomplete. It's really automatic narrative generation. So if you think about autocomplete on if you're sending someone a text message, we all like the little autocomplete that helps finish the word for us, or maybe even suggest the next word for us. But total narrative autocomplete is amazing, right? So this GPT-3 algorithm can actually create an article just with a little bit of information, like what is the topic? And it can then write multiple paragraphs. It's actually extremely scary, but because it's talking about generation of fake news. But the field is so hot with research right now and applications. So whether you're coming at it from the research side or a business application side, or somewhere in between. That is, you want to build technologies and deliver technology. So no matter which sort of dimension of the world you live in, whether the business application user or the business application developer or the researcher developing the algorithm or the data scientist who is just trying to tweak the algorithms and improve them, there's a place for you in that space. So I don't know if any one of those I would pick as go here or go there, because they're all really interesting right now and lots of exciting stuff going.
Gotcha. Agreed. One last thing I want to discuss before we jump to the community questions. Just quickly, analytics maturity. So there's 5 levels, or you outline 5 levels of analytics maturity in data-intensive applications. That's descriptive analytics, diagnostic, predictive, prescriptive, and cognitive analytics. And you also have keywords for each one of those. Could you just give us a quick outline for those of us who maybe have not heard this breakdown or need a refresher on it?
Yeah, thanks for asking. I've actually decided recently not to call it 5 stages of analytics maturity, because people, I realized this even when I was saying it in the early times I was saying it, that sort of gives the wrong impression, but I never could find the right word. So now I call it 5 dimensions of analytics implementations. Mm-hmm. And so you could be at any level there, and that's fine, because it's just a different dimension of analytics. It's not really a maturity question. It's just an application. So the first one, I'll just do them in sequence, not to say one is better than the other. Again, they're just 5 dimensions, is what we would call descriptive analytics. So descriptive analytics basically describes what has happened in the past, describes, for example, how many things did you sell last business quarter. So every business that's publicly traded has to do quarterly or annual business reports. This is required by law. They have to do it. So no one should ever say, don't do descriptive analytics. That's completely wrong. You must absolutely do it if that's required by law. But anyway, descriptive is still powerful, but it's hindsight. It's looking backwards, so to speak. The next one is diagnostic analytics, which is basically real time. So not looking back, but what's happening right now, streaming data. It doesn't necessarily be streaming, but just the current data, the current moment, the data you're collecting, what does it tell you that what's going on? So diagnostic analytics is real time. Okay, so that's basically, oversight, if you will, what's happening now. So we go from hindsight to oversight when we go from descriptive to diagnostic analytics. The next is predictive analytics. So predictive analytics is looking ahead, right? So it's taking the training data, which is the backwards-looking data, of course, but it's building forward-looking models from the training data to see what is next, what is an outcome given the past data. So that's foresight. So predictive analytics is about foresight, looking forward, seeing what's coming. So we've gone from hindsight to oversight to foresight using these first 3 dimensions: descriptive analytics, diagnostic analytics, and predictive. The 4th dimension now takes us back to the things I was saying earlier about prescriptive analytics. Prescriptive analytics tells us if we don't, for example, if we don't like the outcome that's predicted from our predictive analytics model, what can we do to change it? That's prescriptive analytics, and it comes from learning, like I said, those insights from the other dimensions in your data that illustrate or demonstrate or discover for you those causal factors, those causal dimensions in your environment, things that you have control over that you can cause a different future to occur than the one you're predicting. So I like to use an example from astronomy when I talk about prescriptive analytics and predictive analytics, and in fact, descriptive analytics also. And it's called the killer asteroid example. So this is my usual use case, and most people get it, even if you're not an astronomer. So with asteroids, astronomers collect the data, and the data meaning the location and motions of asteroids across the sky. And we see these by the millions. I mean, they're all over the place. Very few of them ever come near Earth. That's the good news. But we just basically collect data points to see where they are, how they're moving, and how big they are, and other kinds of properties like that. So that's just some descriptive analytics. But we can build a predictive model, in other words, an orbit, a trajectory from the data points for an asteroid. For any given asteroid, we can collect multiple data points and build a trajectory, a model for the orbit, the trajectory. We can predict where it's going. So that's predictive analytics. Now, if we predict that this asteroid is going to impact Earth, and if it's big enough asteroid, it could actually wipe out human civilization or all life on Earth, like almost happened, millions of years ago when the dinosaurs were extincted by an asteroid impact. At least that's what we think. So if we build a predictive model and we say, oh, this asteroid is going to wipe out civilization at 12 noon next Tuesday, have a nice day, see you later. I think that people would say to the astronomer, hey, come back. Can't you do something about that? And if I was that astronomer, I would say, oh, you don't want just a predictive model, you want a prescriptive model, right? So the killer asteroids is actually, in some sense, relatively easy, at least in sort of its technical application, because we know what the forces are to move an asteroid. We may not be able to move the asteroid, but we know what the forces are, right? Change the trajectory, change the path, and how you do that, that's up to engineers, but changing the path, changing the trajectory can move it to a different outcome than the one you predict. If we're talking about customers or hospital patients or employees or even machines, sometimes we don't understand necessarily what are the nudges of those things. So prescriptive analytics is looking at all those different dimensions in the data gives us insights into knowing what we can do, how can we nudge the thing to a different outcome than the one we predict. For example, we predict the customer is going to leave. We predict the employee is going to leave. We predict the engine will fail. We predict the patient will get sick and die. Well, if that's true at the doctor's office, what do you ask for? You ask for a prescription. So prescriptive analytics is finding the prescription to change the outcome from the one that's coming, that you predict, but you don't want to happen. So sometimes I say prescriptive analytics is like causal predictive. You're causing a certain future to happen. So we've gone through these four dimensions: descriptive, hindsight; diagnostic, which is oversight; predictive, which is foresight; and prescriptive, which I now call insight. That is, we have enough insight to affect the outcome that we can actually change the outcome. The fifth one in my list of dimensions of analytics is cognitive analytics. So cognitive analytics is where you put it all together in the same way that a cognitive human being would do. You look at all the data and say, what is the question I should be asking? What is the next best action, next best decision, given all of the data? So cognitive analytics is taking in your data with that 360 view from all those dimensions, and from that you get what I would call the right sight. Now that's sort of a play on words. We've gone from hindsight to oversight to foresight to insight, now to right sight. So right sight is, again, the right action, the right decision at the right time in the right place for the right customer or the right product or the right thing. And so cognitive analytics is really the opposite, truly the opposite of descriptive analytics. Because in descriptive analytics, for the most part, you have questions that you need to answer from your data. You go find the results, answers to your questions in the data. Cognitive analytics is about finding the questions that you should be asking. It's not about answering questions that someone has given you. It's about asking the new questions. And that's, again, a very human trait. If you see something odd or weird or strange or emerging or different or interesting, you're going to say something about it. What's that? What is this doing? Why is this happening? What caused that? This wasn't here before. What is it? So we ask these kind of questions all the time when we see things in our real world. Why aren't we doing that with our data? And that's what cognitive analytics is about. So cognitive analytics doesn't have a mathematical formula. It's really about the human in the loop and emulating that human behavior through an AI. You can train an AI and machine learning to find interesting emerging trends, anomalies, outliers, new clusters forming, new correlations discovered, new outliers appearing, new links and associations. So all of these 5 dimensions of analytics, every one of them can be applied to those 4 types of pattern discovery, insights discovery that I previously discussed. They're not mutually exclusive. They're just different ways of thinking about the same thing.
Mm-hmm. And thank you very much for the detailed step-by-step description. It's interesting that you say that they're like none of them is better than the other. Does, for example, an organization need to go through all of them to, for instance, to get to cognitive or to prescriptive analytics? Is it necessary to go step by step through all of these, or can an organization or even like a data scientist jump straight to prescriptive, avoiding the previous steps?
Yeah, it's not necessary to go through all of them, and that's why I stopped, or I'm trying to stop using the word 5 steps to analytics maturity, because it gives the wrong impression that you need to follow these steps sequentially, and that's not true. These are just 5 different dimensions of analytics. So you can choose to jump in anywhere, except it helps to, of course, have experience with some things before you go into something too deep. For example, if you're going to do prescriptive analytics, it's probably a good idea to do some predictive modeling first, just so you can see what are the outcomes, to find ones that you might want to change, and then go exploring the data set, see if you can find causal factors and causal treatments, if you will, that can change the outcome. So just going about prescriptive analytics without knowing what and why you're changing something is sort of not a good business move anyway. So really taking from the business perspective, you just want to think about what are the business goals and objectives. And so predictive modeling is very common. Predictive analytics is extremely common in business analytics applications. But you can take it one step further, just like the killer asteroid case. If someone predicts a bad thing's going to happen for the business, you just don't want to say there, oh, well, we're going to have a bad business quarter. Someone's going to say, hey, can't you do something about it? And then that's the prescriptive model you're going to try to find by asking questions of the data that you didn't think, and that's being cognitive.
Gotcha. Thank you very much. So we still have a bit more time. Are you excited to do some rapid fire questions from our community?
I can try. If they're all yes/no questions, no problem.
They're a bit more complex than that, but let's see how we go. Okay, so Deep Shah asks, can a data scientist work as a business analyst? What extra skills do you need to work as a business analyst? Basically, I guess the difference between data scientist and data analyst.
Well, I'm not a business person, but I can assure you that the more skills you have, the better that business analyst is going to be. But if you're coming at it from a data scientist to becoming a business analyst, then of course what you need to do is understand business. And I'm not saying I understand a lot of business, because my background is not that. But I've gone to enough conferences and talked to enough business people, and certainly done a lot of consulting in the last 5 years at Booz Allen and consulting with businesses. That the more you learn about the business, the more you can help the business. So whether you're going at business from data science to analyst, or from analyst to data scientist, I think the sort of the merger of the two skill sets is what's really going to make you most valuable. And so learn about the business, definitely, because at the end of the day, it's really about solving the business problem and meeting the business goals and objectives, and reaching the business's core mission. That's got to start where you start. It's very tempting as a data scientist to say, oh, I've learned this new cool neural network or deep learning algorithm. Let me find a use case for it. Now, okay, that could be fun, and it sometimes leads to good applications in the business. But think first about why you're doing it, and that's always a good. Even as a scientist, when I was an astronomer, certainly wasn't doing business, but it was about a big goal. It was about a big question that I was trying to answer when I collected data and did my data analysis of those. And so it's really about finding what are the questions you're trying to answer. That's really where you need to start.
Gotcha. Thank you. Next one is from Kareem. How is AI shaping the future of data analysis, and at which stage is it right now?
Well, my company at Booz Allen Hamilton, we have this concept called Analyst 2.0. Of course, I guess everyone attaches 2.0 to a lot of things these days, but Analyst 2.0 is basically the AI enhanced analyst. And this goes back to what I said, that AI is really not about artificial intelligence, augmented, assisted, amplified, accelerated intelligence. And so the analyst can be helped with the AI to help triage the data, as I was saying earlier, find the specific data sets that are relevant to my business questions and my business use case, and help me to analyze that data better using these predictive and prescriptive models, maybe building a predictive analytics or even prescriptive analytics models to do correlation discovery and class discovery and outlier discovery and link discovery, right? So the data science helps the analyst to go beyond just analyzing data to doing the insights discovery and even, like I said, even not just insights discovery from the predictive side, but from the prescriptive side. And so Analyst 2.0 is about using the AI and the machine learning to really augment sort of the traditional role of an analyst.
Gotcha. Makes total sense. AI is, as we discussed, really invading all areas, and I think it's absolutely necessary for everybody to consider the implications on their careers from a data perspective. A question from Neil, also about AI. What do you consider to be the most important ethical issues in artificial intelligence at this moment in time?
Well, there are a lot, of course. A lot of questions people are asking, and a lot of inquiries about what people are doing. And I think in broad terms, I mean, it's leaving the human out of the loop. That's sort of the biggest issue there is to be one. Not just building models and deploying them automatically, but having it looked at by humans, analyzed by humans, understood by humans. And so underneath that is things like explainable AI. That is, can you explain the black box? How did it come to this decision? Also within that category of human-centered AI is the concept of trusted AI. What do we mean by trusted? I mean, does that mean that I trust it? No, it means that a broader audience, a more diverse audience can trust what it's doing and how it's doing it and what data it's using to get to that conclusion. So really, sort of human-centric AI, I guess, would be the biggest challenge in the AI ethics space right now. As much as we want to do this, it adds a burden. I mean, it is a true fact that it adds a burden to organizations to have more ethical reviews and more people looking at the things, and instead of just like when I was doing my astronomy, I wanted to build some model that would explain some property of a galaxy. Well, I could just I would be working late at night on my model, and I can tweak my model and then I would apply it to the galaxy data to see if it worked. Well, I didn't need anybody's approval because it didn't have any effect on anybody's life because it's galaxy data. But what we're doing now, it's like you just can't come up with a model and just deploy it because it's cool. You have to go through a lot more steps. And so I think organizations are thinking more about this, which is why some organizations have not only chief ethics officers but chief AI officers, where they do that governance step, and that's not inexpensive, but it's absolutely necessary.
Agreed. Nabil asks, that's an interesting question. I think you're very relevant in your case. What is the maximum period you have taken off from your profession, and how have you spent that time?
I don't think I've ever taken off. Ask my wife. I don't think I've ever, other than family vacation.
That's what I thought.
Well, one could say, my part of my years at NASA, I was a contract manager, and this small company I worked for had a policy of giving sabbaticals to research scientists in their organizations if you had a good sort of research plan. And you'd been with the company long enough. And so I put in a proposal to do a research sabbatical on some of the astronomical research I was doing in those. And so so I applied and I won the sabbatical award. And much to my surprise, I discovered I was the first person ever to receive that sabbatical award. And so so they basically covered my income for 6 months. And during those 6 months, I actually went back to an office at the Hubble Space Telescope because I used to work there. At that point, I had already been gone from there for 5 years or something. But they provided an office for me just to come back, and I would just sit in my office and have no other responsibility but to analyze astronomy data. And it was during that period where I started investigating more about machine learning and data mining, as we called it, and these algorithms of insight and pattern discovery and data, which was actually completely different from the traditional analysis. I had been doing data analysis for many years, but this machine learning was so different from analysis, and it really sort of changed the trajectory of my career that I was able to take that time off from my normal day job. And even though I was still doing sort of, my profession, that is astronomy research, I wasn't my day job, which was managing a contract, which was, of course, a completely different world. but I was able to take 6 months off from the day job to do this sort of lifelong learning sabbatical, as I would like to call it. I spent 6 months learning a whole new set of skills and algorithms and techniques in science that I'd never learned before. And that was an incredible moment for me.
Amazing. Have you ever thought of taking some time off and just going and relaxing and not doing anything?
Well, we try to do that every summer, my wife and family and I. And this summer, of course, is different from all summers, so we haven't done that this year. But we go up to Lake George up in upstate New York. I don't know if anyone's familiar with that, but it's a beautiful lake country up there in Lake George. Absolutely beautiful lake, and we spend some time up there. And it's actually a lot of work because we got to get the house open and cleaned and ready, and so it's not like it's a lazy vacation, but it's certainly different and fun, and really once we get everything cleaned and opened up, then it is a lot of relaxation, hanging out in the sun.
Absolutely.
But the most exciting thing is it's way far away from any bright light city, so we go sit out on the dock at night, and the stars you can see in the sky is just unbelievable. I mean, I forgot that's how I got interested in astronomy as a child, but nowadays it's so hard to find a really, really dark sky, especially when I live near a big city. But when we go out to that spot where it's just like can be completely black out, you can't even see your hand in front of your face, like they say when you walk out the door. It's just reminds me of my youth and how I first got inspired to want to understand the universe as an astronomer.
Amazing. Well, that sounds wonderful. I hope once the coronavirus situation settles down a bit, you'll get a chance to go there and enjoy that once again.
Yes, thank you.
Awesome. Well, Kirk, thank you so much. We're running out of time. This has been a fantastic podcast. To finish off, I wanted to say that to everybody listening that Booz Allen Hamilton is hiring. We actually spoke with Kirk about this right before recording, and you can go to careers.boozallen.com. There's over 200 data science jobs right there now, and over 1,000 jobs that mention the word data. I've actually learned about Booz Allen, and it's a huge company that does a lot of work with thousands of employees around the US and possibly even around the world. So highly recommend for everybody to check this out, careers.boozallen.com. And Kirk, please could you share with us how can our listeners find you, connect with you, follow your work, attend, I don't know, maybe yet another keynote session that you will be giving? What's the best place to stay in touch?
Well, I'm extremely active on Twitter. So my Twitter handle is Kirk D. Borne, the middle initial D for Daniel. So Kirk D. Borne on Twitter. I'm most active there. I'm also on LinkedIn, just as Kirk Borne. Usually when I'm giving talks places, I will post the announcements there. But in general, on Twitter, I'm just sharing a lot of information about data science and AI and machine learning, digital transformation, Internet of Things. A lot of stuff I put there every day. So I just call that my micro education platform.
Mm-hmm. And micro is a huge understatement. You have over 260,000 followers on Twitter. So everybody listening, join the little club that Kirk has created and get all the insights. That's fantastic. Kirk, one more question before we finish up. What's a book that you can recommend to our listeners to help them become better in data science or just inspire them in their lives?
Yeah, it may not be one that people have heard of or be surprised when I say it, but there's this book called Data Mining Techniques. There's actually published now in its 3rd edition, Data Mining Techniques for Marketing, Sales, and Customer Relationship Management. Wow. It's written by Gordon Linoff and Michael Berry. And the reason people might say that's unusual, because why would an astrophysicist, data scientist recommend a book on marketing, sales, and customer relationship management? Mm-hmm. Well, for me, an earlier edition of this book, now this one is much more expanded and larger than when I first found it, which was like the 2nd edition years ago. When I discovered this book, I realized in reading it that it finally made clear to me all of these different algorithms that I was learning. So when I first learned about neural networks, I mean, I could sort of mouth the words and talk about, hidden layers and inputs and outputs and activation functions. I could mouth the words, but I really just didn't fully grasp what I was talking about until I read this book and the applications, not only of neural networks, but all kinds of different algorithms that we learn in data science and machine learning beyond the math, but actual in real life business applications, real world applications. And I found it's very informative, surprisingly so, to understand these algorithms in a business application context. So I highly recommend it, especially make sure you get the latest edition. That's Data Mining Techniques, the 3rd edition by Linoff and Berry.
Thank you very much. Data Mining Techniques for Marketing, Sales, Customer Relationship Management, 3rd edition. Indeed, it is surprising to hear that recommendation. However, makes total sense. Yeah, put these things into real life examples. It probably helps remember, understand.
Yeah, and I'm going to post that. I'm going to post that on my Twitter feed right when we're done, so people can go search my Twitter feed whenever you hear this, and hopefully you'll find a link to this article or this book, if you haven't found it already.
Fantastic. Well, Kirk, thank you so much. It's been a pleasure to have you on the show.
I appreciate it very much, Carol. It's been great. Thank you.
So there you have it. Hope you enjoyed this podcast. Hope you picked up lots of valuable insights. I loved that we talked about several different frameworks, including the 3 broad categories of AI and data science applications, 4 types of data discovery, 5 dimensions of analytics implementations, and more. My favorite part of this podcast was graph analytics, and it was a revelation to me when Kirk said that it is, in his opinion, one of the most powerful, if not the most powerful type of analytics out there, and it really made me think. And that's why I asked the question, how can people get into that space more? And based on how he describes it through the network sciences and other examples, use cases that sample use cases that he mentioned, indeed, it is probably one of those more advanced types of analytics that is yet to be explored by many. So the people that get there first are going to be highly in demand. They're going to be bringing lots of value. It's also going to be a lot of fun discovering this new type or progressing this new type of analytics. And I have an important announcement. I just spoke to Kirk right after the podcast, and he agreed to come and join us for our Data Science Go virtual event. So if you haven't registered yet, head on over to datasciencego.com/virtual and register. The event is on the 25th/26th of October. It's absolutely free to attend, and you're going to have lots and lots of fun being there with us. You will hear from Kirk and many other exciting speakers. There'll be workshops, plus you will get to network with other data scientists from all around the world with our speed networking functionality. We're expecting about 5,000 data scientists this time, so make sure to jump in and join the fun. Again, that's datasciencego.com/virtual. And as always, if you enjoyed this podcast, you can get the show notes at superdatascience.com/397. That's superdatascience.com/397. There you will find the transcript for this episode, any materials that we mentioned, show notes, and any links, including a URL for Kirk's LinkedIn. Make sure to connect, and a URL for Kirk's Twitter. Make sure to follow Kirk and see what he gets up to in the near future. On that note, thank you so much for being here today. Kirk and I look forward to seeing you at Data Science Go #2 at the end of October this year. And until next time, happy analyzing.